Wrapping up our series from section 4.4 in our textbook, we've got two more examples where we're going to find the intervals of concave up and concave down and inflection points for functions. Last time we talked about increasing and decreasing intervals, relative local max, local min values for y equals sine x plus cosine x on the interval from 0 to 2 pi. Now I want to talk about concave up and concave down behavior for this function. This was the derivative that we found when we were talking about this function earlier. I start by calculating the second derivative, and I get minus sine x minus cosine x. And as before, I want to solve y double prime equal to 0. Well, I can move things over here, and I get minus sine x equals cosine x. And so this time I need the sine and cosines to have opposite signs, but have equal absolute values, but be opposite signs. Sine and cosine are opposite signs in the second and fourth quadrants, so I'm looking for angles there. And again, thinking about plus square root of 2 minus square root of 2. So if I'm in quadrants 2 and 4, the angles are going to be 3 pi over 4 in the second quadrant and 7 pi over 4 in the fourth quadrant. And so again, I'm going from 0 to 2 pi. 7 pi over 4 is going to be something like here. 3 pi over 4 roughly here. I need test points. I'll use pi over 2 here, pi here, and I'm kind of boxed in to 11 pi over 6 here. And so I need the sine of y double prime. So y double prime of pi over 2 is minus sine of pi over 2, that's negative 1, minus cosine of pi over 2, that's 0. And so I get a negative value here. Y double prime of pi minus sine of pi, that's 0, minus cosine of pi, that's negative 1. So I get positive 1 out of this because I'm subtracting negative 1. And then lastly, y double prime of 11 pi over 6. In the fourth quadrant, the sign is negative, and so I'm going to get minus negative 1/2 minus cosine of 11 pi over 6 is going to be square root of 3 over 2. It's positive in the fourth quadrant. And so this is going to be the square root of 3 over 2 minus square root of 3 plus 1 over 2. That's a negative quantity. And so the behavior of y, negative second derivative, it's concave down, positive second derivative, it's concave up, negative second derivative, it's concave down. So y is concave up between 3 pi over 4 and 7 pi over 4. It's concave down before that and after that. And then inflection points, y of 3 pi over 4 is equal to sine of 3 pi over 4 plus cosine of 3 pi over 4. That's equal to the square root of 2 over 2 minus the square root of 2 over 2, which is 0. And we get something similar at 7 pi over 4. I get negative square root of 2 over 2 plus square root of 2 equals 0. So I have inflection points at 3 pi over 4, 3 pi over 4, comma 0, and 7 pi over 4, comma 0. My last example is a little bit more involved. Y equals 16x over x squared plus 4. We had to go through the quotient rule to calculate the first derivative. I'm going to start here. I've just got all the steps here just for you to review to make sure you understand how we got this derivative earlier. And I get to apply the quotient rule again to calculate y double prime. And so it's the derivative of the top So it's going to be minus 16 times 2x times the bottom minus the top times the derivative of the bottom. And I get to use the chain rule to calculate the derivative of the bottom. That's going to be 2 times what's inside times the derivative of what's inside. And if I square x squared plus 4, quantity squared, I'm going to get x squared plus 4 to the 4th power. Now at first this looks like it's a pretty big mess to try to deal with, but I'm going to try to show you in steps what's going on. So first of all, notice that I've got two terms here in the numerator. I've got the first term here and the second term here. And I'm going to pull out common factors. So I want to identify common factors here. Well, it looks like I got a 16 to pull out. I've got a 2x to pull out. And I've got 1x squared plus 4 here and 1x squared plus 4 here. So let's see what we can get out of this. I've got, if you'll allow me, I'm going to multiply the negative 16, or just I'm going to take 16 and 2x here. And so I'm going to have 32x times x squared plus 4. And now I'm going to see what's left behind. Okay, well, I've pulled everything out except one of these x squared plus 4's here. So I'm going to have a minus x squared plus 4. And then I've got a minus here times a minus. That's going to be a plus. So this is basically going to be make that a plus there. And I've pulled this out, and this out. And so it's going to leave me with 2 times x squared minus 4. So I've got this x squared minus 4 here, this 2 here. And that's all over x squared plus 4 to the 4th. Now notice I can cancel this with one of these, leaving me with a 3. And so now I've got 32x, and now I'm going to try to distribute and collect some like terms here. So I've got x minus x squared plus 2x squared. It's going to be with x squared, and I got minus 4 minus 8, that's minus 12. And so after a little bit of labor, I've got this written as 32x times x squared minus 12. And so what are the places where I need to take a look? Where is y double prime equal to 0? Well, a fraction 0 in the numerator is 0, so I'm going to look at 32x times x squared minus 12. Set equal to 0, so x is 0, or x squared is 12. And so x is 0, or x is plus or minus the square root of 12. And the square root of 12 is about 3.4. So that's to one decimal place, that's what we want to be thinking about. So I've got my critical, they're not critical points, that was for the first derivative, but they're the places where the second derivative is equal to 0. And again, notice that x squared plus 4 is always positive, so the denominator is always going to be a positive quantity here. We're not going to be looking at that. So here's my number line. I've got negative square root of 12, 0, and square root of 12. I need some test points. So I'm going to choose negative 4, negative 1, 1, and 4 here. Extend these number lines out a little bit. And so now I'm going to do what I normally do. I'm going to find the sign of y double prime. And so I'm going to be plugging in to this version up here. It's going to take a little bit of effort, but I've got 32 times negative 4 times negative 4 squared, that's 16 minus 12 over 16 plus 4 cubed. So this is a product in the numerator. This is negative. This is positive. The denominator is always positive. So I've got a negative times a positive over a positive. That's less than 0. So this is y double prime of negative 4. Y double prime of negative 1 is going to be 32 times negative 1 times 1 minus 12 over 1 plus 4 cubed. This is negative, this is negative, this is positive, so I've got negative times negative over positive, that's positive. Y double prime of 1 is 32 times 1 minus 12 over 1 plus 4 cubed. I've got a positive times a negative over a positive, that's a negative. And then lastly, squeeze it in here, 32 times 4 times 16 minus 12 over 16 plus 4 cubed, positive, positive, positive everywhere, that's positive. So then I've got the behavior of y. I'm going from concave down to concave up to concave down to concave up. So y is concave up on negative root 12 to 0 and positive root 12 to infinity. It's concave down before negative root 12 and between 0 and root 12. And inflection points, well, let's look at what y of the square root of 12 is. So let's go back and remember y was 16x over x squared plus 4. So y, let me tidy that up just a little bit. Y of the square root of 12 is going to be 16 square root of 12 over 16, which looks like it's going to be square root of 12, and y of negative square root of 12 is going to be 16 times negative square root of 12 over 16. I get negative square root of 12. And so the inflection points are square root of 12, square root of 12, negative square root of 12, negative square root of 12, and if we plug 0 in as well, we get 0, 0.